Alright, let's do some examples. Here we have a parallel circuit, RC. First we'll find XC. It's 1 over 2 pi times 15K times 4,700 picofarads. So that comes out to 6.28 times 15 EE3 times 4,700 EE negative 12. And if I inverse that, I get 2258.66. And then I go 1 over that to get the susceptance, which is actually 0.30 4427. The conductance of the resistor is 1 over 3300. So 3300 1 over x is 0.00030303. So the total admittance is going to be 0.000300303 plus J 0.0004427, or if I do this in terms of micro, 1, 2, 3, 4, 5, it'll be 303 micro plus J 442 micro. Let's see. Okay, so we got 303, 443. Now to get this in terms of polar form, 303 micro squared plus 442 micro squared, and that's going to be 303 plus 442 square root is going to be 535 microsiemens is the total. And there's the 535. Now the angle theta is going to be the inverse tangent. Now it's opposite, so it's going to be a 303 micro over 442 micro. So it's 303 divided by 442. 303 divided by 442 inverse tangent, and I get 34 degrees. That's wrong. Stop here. 1, 2, 3. One, two, three, begin. So it's the inverse tangent of 442 divided by 303. That comes out to 55.56 degrees. And there's our angle right there. An inductor. Alright, first we find x of L. So it's 2 pi times 800 hertz times 75 millihenries. So that's going to equal 6.28 times 800 times 75 milli is 376.8. I go 1 over XL. That's going to be 0.00265. 1, 2, 3, 4, 5, 6. That's 2653. 2653 microsiemens. Conductance is going to be 1 over 560, which is 1, 2, 3, 4, 5, 6, 1785 microsiemens. Now Y is going to be 1785 micro minus J 2653 micro. Then I want to find the polar form, 1785 squared plus 2653 micro squared. That's equal to 1785 squared plus 2653 squared is equal to that. Square root is 3197 microsiemens is the total. So we've got, they did in milli, okay, 32, but the numbers match. And the angle then is going to be the inverse tangent of 2653 divided by 1785, so 2653 divided by 1785, inverse tangent, 56 degrees. Alright, so next, if we take, let's do another problem here. R and L. So x of L is going to be 2 pi times 100k times 1 millihenry. So that's going to be 6.28 times 100k times 1 millihenry gives 628. And BL is 1 over 628. So that's going to be 1.59 milli Simons. G is 1 over 470. It's 2.12 millisimons, so Y is going to be 2.12 milli minus J, 159, 1.59 millisimons. So we have our G and our L. We can get our Y in terms of polar. It's going to be 2.12 squared plus 1.59 squared. So 2.12 squared plus 1.59 squared square root is 2.65 millisimons, and the angle is going to be 1.59 over 2.12 milli. 1.59 divided by 2.12. Inverse tangent is 36.9 degrees. And multiplying by 5 volts will give you the currents. And then we have parallel or LC circuit, which is a tank circuit. And without the resistance here, when we are at resonance, the capacitive current and the inductive current are at 180 degree opposite. So you basically have both of their values canceling each other out. So ideally, the tank circuit could run continuously. And the current is at a minimum here at the resonant frequency. And if you take the output voltage across when you're at resonant, you'll be at a maximum output voltage because it's seen as an infinite amount of resistance. And since our infinite amount of resistance is up here at resonance, this basically has nothing. So there's no output voltage there. So we have a band pass circuit and a band stop circuit.